All right, I think I will take advantage of this lull in conversation probably to go ahead and make a start. We've given it a couple of minutes. Once again, hello everyone, and welcome to PERCxR with an X at IEEE 2022. This is, as you probably know or may not know, the eighth year we've been running PERCxR. I have not been involved in all of them. I think some people in the room probably have been involved in all of them. It was started as perceptual and cognitive issues in augmented reality. But in the last couple of years, as sort of augmented and mixed and virtual reality have started to blur together in many ways, we've expanded it, much like the parent conferences that it's associated with, to involve all perceptual and cognitive issues across mixed, all types of mixed and mediated reality. Last year, it was not held at IEEE for various reasons associated with COVID and schedules, but we did hold it for the very first time at ISMAR. Thanks to the hard work of our co-organizers, Missy Smith, Nayara Furia, and Etienne Payard, who made it happen last year. So we did not have a year without a PERCxR. But going forward, and this is a topic that will be up for discussion when we retreat to the Miro boards later in the Miro boards in the breakout rooms later in our session, is what PERCxR will hold going forward, right? Because I think that we are interested in potentially continuing to have it run at IEEE and at IEEE ISMAR, because it is a lovely big community as we're seeing here, and we're interested to talk about how we can differentiate those workshops so that, you know, it's all under the PERCxR umbrella potentially, but maybe it has a different focus at ISMAR than it does at IEEE VR. So we welcome comments, feedback, thoughts about that. As I've already mentioned, this workshop is not solely organized by me. There are 4 of us who are co-organizers: myself, Rick Skarbez, Missy Smith in the Zoom window to my left. You know, I don't know where she's showing up on your screen, and Nayara Furia from Virginia Tech, and Etienne Payard from IMT Atlantique. Is that correct, or did I give you your correct affiliation? Yeah, but we are all very glad that you're here, and we're really excited about today's program that has a really exciting keynote, some really exciting speakers, and then a hopefully really exciting, I'm sure it will be because we'll be hearing from all of you, interactive discussion session. So that's the program, and with that, I will turn it over to Nayara, who's going to introduce our keynote speaker. Take it away.
So yeah, as Dr. Rick mentioned, today we have Dr. Gabbard. I could talk many good things about him, but I need to give a formal introduction of my advisor, who happens to be our keynote speaker today. So he is an associate professor of human factors at Virginia Tech. Dr. Gabbard holds a PhD, master's, bachelor's degrees in computer science, HCI, and also a bachelor's of arts in sociology, also from Virginia Tech. His work centers on human-computer interaction in augmented and virtual reality. For nearly 25 years, Gabbard has been researching new methods of design and evaluation of interactive virtual and augmented reality systems. Currently, Dr. Gabbard is the director of the Cognitive Engineering for Novel Technologies Lab at Virginia Tech, conducted basic and applied HCI and human factors research. Without saying that much, I want to welcome Dr. Gabbard as our keynote speaker. Have the floor to yourself.
Hey, thank you so much. Thank you so much, Nayara. That's a gracious introduction. And I also want to thank really a bunch of people really quick, including all the students that I've had the fortune to work with over the years, whose efforts without which I would have very little to speak about probably. And also, of course, Dr. Tabitha Peck, who's hosting a satellite event here in Davidson, as well as all of the attendees that are here with me. So I'm going to show you all. I'm in a space here. It's a really nice, it's a really gorgeous space. Sort of a pit-like area with really great old building behind me, and several attendees that are here as well. These are these are real people. They're not virtual. And then, of course, my family for supporting me over these years. So let me start by sharing the correct screen if it will let me. Okay, so let's get rid of some windows. Can you see the PowerPoint okay? Oh, I can just turn around and look. That's convenient. So I'm going to apologize in advance. I have to do this interesting balance between looking in the camera and all of you all that are remote and the folks that are here. So when you see me looking up in the sky, that's because I'm looking at the folks that are here. Right. So today, I feel quite humbled to follow in a long line of really great keynote presentations at ISMAR. Except for I'm not presenting at ISMAR, at PERCxR. And I remember the first year it was Steve Ellis and then Steve Feiner. So we had the two Steves. Bruce Thomas, whose work in color, interface color inspired some of my early work. Henry Du, Anthony Steed, Bobby Bodenheimer, and my colleague and good friend Ed Swan last year at ISMAR. So this is a really great list of keynote speakers throughout the years at PERCxR, and it's again quite humbling just to be part of it. So thanks again to everybody. I am going to talk a little bit about my perspective on what I see as emerging AR user interface trends, kind of the good and the bad and the ugly. Although I didn't use that as subheadings. There's some trends that I've noticed in researching the evolution of interfaces. I guess you could consider them biases. This is maybe the wrong community to speak about biases because, of course, there are many formal, important biases we need to be aware of. It's more like trends than biases, and then as well as opportunities that will allow us to grab hold of the future and maybe create better user experiences for those AR users, right? So Nayara, thank you for the introduction. So I don't need to go back through this, but I want to show the fun picture because without the students, right, the work that we do is there is no work, and we have a lot of fun. This is an older picture, but we try to pull out all the old displays and take a shot when we can. We engage undergraduate students and postdoc researchers as well. As Nayara alluded to, one of our goals is to create principled UX or user experience approaches for AR. And really what it comes down to is trying to understand this connection between AR interface design and human performance and human behavior. So because they are intrinsically linked. And so we're not so much a design shop, right? I don't think we have the skills to be really great designers. We are good at UX, and we are good at kind of measuring the effect of what those interfaces can do to folks, good and bad. But it's that middle piece about design that I find intriguing, maybe because I'm not that good at it. And that's why I've been thinking a lot about that, and we'll talk about that. So we do a lot of human factor studies and user studies on all sorts of different platforms. I've had the fortune to work in handheld AR, of course, head-worn, a stent, and with driving related AR head-up displays, as well as some more recent work with video pass-through AR. So, drones with cameras on it or semi-autonomous robots. So teleoperation in a way. But so in all these spaces, though, our work often has one foot in the basic science space and then another foot in the applied space. And so we ultimately end up engaging representative users, doing UX work, and attempting to design interfaces. And sometimes I think we hit the mark, and sometimes I think we could do a lot better. And so over these years, I've been thinking about interface design and kind of how we got to where we've gotten, and what's the baggage that we bring with us when we kind of enter that design space. So I would be remiss without naming a few folks. I can't talk about augmented reality user interface design, in my opinion, without giving credit where credit's due. And Steve Feiner's group at Columbia, I think, has done just an incredible amount of interface thinking throughout the years, consistently. And so this is part of my story in the sense that Dr. Feiner's work at Columbia, created this early personal Turing machine in '97. It evolved into a mobile augmented reality system, or MARS, in '99. And then through a collaboration between Columbia and the Office of Naval Research, this battlefield augmented reality system was created. And that was actually my graduate work, was attempting to do user experience with this one of the first outdoor mobile AR systems. And we were learning a lot about AR interface design even at that point in time. So I would be remiss if I did not show a photograph. I'm a little bit sad because Dr. Swan is supposed to be here, but here is a photo of Dr. Swan and I doing UX work a long time ago. And so you can see we've got, our military officer here, or not officer, but our military personnel, or subject matter expert. And we're applying traditional UX methods, right? And they were okay in terms of understanding what users' needs are, what are their tasks, what information interactions are important in those stressful times. However, when we tried to translate those findings of that early UX work to actual UI designs, we were humbled. We were doing our best, right? We were leveraging our past knowledge of, existing GUI designs and other interface designs. We had done some work in VR, but we really were just taking things and throwing them into an AR space and saying, oh, what do you think, stakeholder? And so we took a step back. We made a long list of core issues that we felt were impacting the user experience. Many of these can be attached directly to the user interface, some not. This is not sort of our unique list. If you go back to this time period, you'll see in the literature a number of lists that are very similar to this. And I've highlighted just a few things that I feel like really were foundational pieces that the community but the community addressed over the years, and including a lot of folks in PERCxR. So, distance perception and estimation, information clutter and layout. Dr. Feiner did a lot of great work on that. Myself and others did work in color perception. So these core issues that were identified early, really, we've been chewing on them for a while, so to speak, right? And we've made good progress. And so, but we're now at a point where we need to think about how we're designing and what we're designing with, and whether or not the tools that are available to us are the best tools for designing AR interfaces, or where they fall short. There are pros and cons to the existing suites that I'll address shortly. And I'll just say that list of issues I was just showing helped kind of formulate a number of interesting collaborations in court, including one between Ernst Cruyff and Dr. Swan and Steve Feiner, resulting in this Perceptual Issues in AR paper in 2010 that, in effect, I think, created PERCxR shortly thereafter. So there's a little backstory on how PERCxR was born. But throughout all, so for me, PERCxR is interesting because, or the idea of studying perception and cognition in AR is interesting, not only because of the sort of fundamental underpinnings of the human experience that we get to examine. That's certainly fascinating. But to me personally, it's, what does that mean for the interface design? And I think there's a number of us in this PERCxR space where that resonates, right? Where how does my work inform a user experience ultimately? And so that's really that's really kind of the shared, in a way, a shared vision that we can embrace. So for today's thoughts, right, and these could change tomorrow, I'm just going to talk briefly about kind of where we are in terms of AR interface design, and in a way how we got here. This is kind of my perspective on some of the trends that shaped, in my opinion, how we got here, and then what can we do to move forward. Okay, so let's start with where we got here. So I've been thinking about this for a while, and I started, like a lot of us in AR, and I should say this talk is almost exclusively about AR. I'll mention VR here and there, but I went through a time where I was like, oh, yeah, I work in augmented reality, right? It's this new thing. It's very different. Yeah, all the UX stuff, it doesn't really apply. We need to reformulate all this. And then I had this existential crisis, right? Like where I was like, wait a minute, maybe AR isn't a fundamentally new UX problem. Maybe it's just, maybe it's just a different version of the problems we had in the past. Maybe an interface for AR or user experience for AR doesn't necessarily need to be fundamentally different than what we know from our work with GUIs or with tablets and mobile phones. I don't know. And so I rephrased the question as what makes AR different? Because I was trying to convince myself of this first question. I wanted to convince myself that AR was a fundamentally new UX problem. And so to do that, I kind of backed up and said, well, what makes AR different then? And so there's a couple of different perspectives on this. There's lots of answers, right? But if we go back and look through traditional interactive systems and their interfaces, it doesn't matter sort of if it's a command line interface, graphical user interface, touch-based tablets, large, tiled high resolution displays. In all of these cases, there's a couple of different things that I think are important to note. One is that in AR, as opposed to these environments, the AR information is not sort of simply in the environment, right? Like I go to my desk and I work, but instead the AR interface is critically integrated into the environment and into the work. So not just the environment, but everything about it. So it's not so much in the environment as it is part of the environment. And I think maybe more fundamentally than that is that unless you're playing an AR game, and there's probably some other fringe cases I'm not thinking of, AR is not the primary task. So all of these other interface designs, these UX efforts are focused on creating an experience that, for the most part, right, that's the primary task. But AR shouldn't be the primary task. AR is supporting some important primary task. Is it driving? Is it surgery? Is it, some work in manufacturing or assembly? The list goes on and on. We all know, right? So we have, as designers, we have to keep this in the forefront, because you can make a great AR interface that's engaging, that people really want to use and touch and manipulate. But if ultimately, if it detracts from the primary task, it's not a good it's not a good AR user interface, at my point. So, okay, so in some other ways that AR is different, traditionally we have, sort of displays that we put in our workspace, and, we can think about designing for a primary task, and then we've got sort of our AR information as this red space. And, we can create separate views, and we can create overlapping views. We can create these integrated views. And this is a nice space, right? Because it allows us to think about where do we put AR information when we are designing interfaces. We don't have to put it in a fixed location on a monitor or on a large screen. We can put it in lots of places, but we should think about sort of what I said earlier about it being integrated in the environment and it not being, AR not being the primary task, right? It needs to support the primary task. So we have these options. So I've thought about this a little bit more, and I'm like, okay, I'm happy saying that AR is a fundamentally different kind of UX endeavor. I'm okay with that. So then what does it mean if we agree? And if you don't agree, that's great. We can talk through Discord, or you can find me later in the week at the conference, and I would love to talk about this. But for now, we're going to agree that AR is fundamentally different than a traditional digital design experience. And so what does that mean for design and evaluation? What does that mean? So I have another slide deck on evaluation, but today we're talking about design, of course. Well, let's think about the canvas that a designer has. And I like to use these old photos because it makes people think, oh my gosh, he's going to go back to the Renaissance and walk us through. No, I'm not going to go that far back, but I am going to go a little bit back. But if you think about paper, artist canvas, digital, even the modern era, digital displays, the space in which a UX or user interface designer, right, that canvas has been this bounded two-dimensional plane. And I use the word bounded intentionally, because designers will tell you, digital designers will tell you, we have limited real estate, right? And it's a 2D plane for obvious reasons, right? We're delivering them on modern displays, visual displays. And so this is where we come from, right? And even though, yeah, we had these nice 3-dimensional monitors for a while that were popular, and we got a little bit more than a 2-dimensional bounded plane, our phones, tablets, surfaces, this is the space that we're in, a bounded 2D plane. And this space is quite mature, right? That's good news. That's good news. And so for me, when I opened up the HoloLens 1 in 2013, while most everybody was like thinking and talking about the field of view, which was understandable, my thought was this: do I really have to interact with more 2-dimensional planes? Now I know there's 3-dimensional objects and holograms that we can put in the world, and we can interact with those. But I'm kind of talking about the other parts of the user interface that accompany the 3-dimensional models, right, or the holograms. They're all put on 2-dimensional planes. And if you look at them and kind of pick them apart, they're not that different than the kinds of widgets and layouts that we have on tablets, and maybe even back before that, but mostly more on the modern desktop and tablet platforms. And so I thought, we're really just going to take all of these approaches from the desktop and tablets, and we're just going to put them on planes around us, and then we're just going to say, okay, yeah, that's going to be our AR experience. And so the answer is, yeah, we do have to interact with more 2D planes for now. But why, right? But why? And so I would say, I have given this a little bit of thought, and this is one perspective, and I'm eager to hear other perspectives. I had this kind of philosophy that designers take what we know, what we're comfortable with, and we push it forward, regardless of whether or not the technology can do a lot more. And there's a lag between what the technology can do in terms of user experience and what what designers kind of offer up on those platforms. There's a gap in time, and it's understandable. It's almost, it's human nature in a way. And there's plenty of examples, right? So I'm gonna conscript Dr. Peabody and Sherman. We're gonna grab the Wayback Machine. If you don't know what the Wayback Machine is, don't worry. I can get you a Wayback Machine and take you back, and then you'll know what a Wayback Machine is, to 1963 for just a quick few slides to kind of illustrate this point. This point that interface design and innovation in interface design lags the technological capabilities that we have at hand, right? We have AR technology and other technology in hand right now. We can do some really interesting and compelling, groundbreaking interface development, but it's human nature to take what we already know and grab it and just kind of throw it into the space. And so here's a couple of examples. This is another one of the slides where students roll their eyes and say, oh, here goes Dr. Gabbard talking about the good old days of mechanical teleprinters and teletypewriters. But these are the early computers, right? These are machines connected over a wire. Information comes across, and we have the serialization of information, and the output is literally text that's printed out from left to right, top to bottom. And when you go to interact with the system and you input, you're entering information from left to right, top to bottom. So the serialization, right, printed out like this. And even as we move to digital displays, these interfaces looked like their predecessors, right? We had just digital versions of the text that was left to right, top to bottom, on the output and on the input side. And, yes, as we proceeded through time with the interface development, we had kind of fancier characters that we could mess with, right? Which started to look like, okay, maybe we can do some blocking and some organization of characters instead of just streaming out text. But essentially, right, we're still kind of clinging on to the older layouts. And in fact, this computer is near and dear to my heart, which makes some folks laugh. We have one of these in our lab. Unfortunately, it's not plugged in. It does work though. I remember having this computer when I'm not going to say how old I was, but I remember having this computer, and all of the interaction was command line based. All of it, unless I was playing a game. And I had a lot of games, of course, because that's what you do when you're however old I was. So it struck me odd that this computer had the capabilities to do graphics, but the interface was still this terminal command line interface, right? This text-based interface. It didn't strike me back then, but more, later in my professional career, it struck me that why did this computer have this capability, this graphic capability, but it did not have a graphical interface? It didn't, right? So computers had this capability, but didn't have GUIs. But of course there were GUIs, right? They were in the research space, not yet out in the commercial space. And this is, in a way, kind of where a lot of us are right now, but I don't know for how much longer. So us researchers in AR space, in the AR interface space, we have the chance to forge a lot of the important, innovative, creative, engaging, new, novel interface elements like that was done at Xerox PARC back in the day, right? I mean, this has been happening, to be clear, right? I'm not saying that let's start right now, right? I mean, this has been happening, but there's still an opportunity to keep going with this. And so, yes, these were born, we've got this infamous graphical interface that was kind of tucked away at Xerox research space that Steve Jobs went and saw, and then the rest was kind of history. But in the parallel commercial interface, even into the 90s, we still had these text-based interfaces. So again, I'm speaking to this lag in technical capability, in what could be an interface, right? The computer had a graphics card, and then kind of what designers were working with. It wasn't until there was a disruption in the space where we closed the gap, right, between what the computer could do, graphics, and what designers were doing, graphical interfaces, right? And so we can work through the different years to see, obviously the evolution of the GUI, which is an interesting story in itself. Some people would argue that it wasn't until Microsoft 3.1 that the windowing GUI really had incredible penetration. That was in part due to the low costs of personal computers at that particular time. So even though we had GUIs in the research pockets, it wasn't until the market was ready to be able to produce interfaces at scale where we saw this type of GUI penetration. And I wonder how close we are to this with AR, right? So when, and for that matter, maybe we're there with VR right now, right? So the devices are going to go out there, and people are going to, not the computer scientists and the human factors folks and the researchers at VR and PERCxR and ISMAR, right? But just people. And they're going to say, okay, this is the interface, and they're going to accept it. They're going to learn it. And a few people will critique them. And then before we know it, right, that's what the interfaces are going to be, right? How long have these windowing systems stayed around? There was a similar lag in mobile phones, where innovation in UI design lagged the technical capabilities. I tell this story. I mean, you can look at some of these icons on this BlackBerry, and the symbology, some of the layouts, they just were brought from the GUI world. And I remember having that phone on the left, that Nokia phone, when I first could load my the very first web page. And that was the last time I loaded a web page on that phone, because it wasn't designed to be delivered on that format, and so it was unusable. Right now, I think there's a shining light on this slide, which I think is kind of the wearable space, because I think now that gap is getting closer. Now there's an appreciation of the form factor, right, of the capability of the device, and the designers are better tuned into innovating on that space instead of just grabbing what we know and love and saying, can we just jam it onto that watch? Because you can't. And so I'm hopeful that we can close this gap, but we need to be cognizant that this gap exists, and that we don't fall into this trap of just taking the best, iOS widgets or Microsoft widgets or Magic Leap, or you name your favorite company, and then throwing them into an AR experience and saying, that's the best we can do. So, I have this interesting story about the scroll bar. There is I believe there's this lag, right, between the capability of the hardware and the UI or the UX experience. The scroll bar, right, has been around for a long time. It's changed as the hardware has been innovated, but it really wasn't until this multi-touch trackpad came along where the scroll bar is almost now extinct, right? So I think I can do this. Let me see if I can crash my keynote. That's always a good goal, right? Right. So if I go to a modern browser in Mac, right, and trying to find my mouse, here it is, right? There's no scroll bar over here. There's no visual scroll bar. But as soon as I touch my trackpad with 2 fingers, oh, there's the scroll bar, right? But then I let up, it goes away. So it's almost gone, in part, in my opinion, to this hardware innovation, right? This technical capability innovation. So, but there was a gap there too, right? The multi-track touchpad came out in 2008, and it wasn't until 2011 until the UI designers thought, or the interaction designers thought, why are we manipulating the scroll bar when we can be manipulating the content directly? So I remember waking up and opening up my MacBook and opening up a web page, scrolling with 2 fingers, and everything was backwards. So down was up was down. And I thought, what the heck is going on? Because I had learned for however long, right, decade and a half, that no, when you scroll down, like the page goes up, right? Because you're manipulating the scroll bar, not directly manipulating the content. And it wasn't until the designers felt like, we are grabbing with 2 fingers this surface. Why aren't we directly manipulating the content? Let's not manipulate the scroll bar anymore. And so that was like a step forward. Yeah, and there's still debate. This option is still available, right? There's still debate about which direction is the correct direction. And there is no correct, right? It's just, are you manipulating the content, or are you manipulating the scroll bar? Which do you want to manipulate? But I can't help to wonder, what would Steve Jobs say? Because I didn't think he was big into like, let's give users all the options in the world. Let's just do the one that's the best, right? So, okay, let's go back to AR. So I'm talking about the fact that UI innovation typically lags the technical capability of digital system. And so we have AR, right? It's got some great capabilities, yet I still feel like I'm having to interact with a bunch of 2D planes. Do I have to? And so yes, for now. But what can we do?
Welcome to the playground.
I'll show a little video from Microsoft.
We spent years exploring and refining interactions for HoloLens 2. And the playground is just a tiny sampling of the many prototypes that we built, tested, and learned from. Our approach is basically to try out as many things as we could and look for the things that stood out. So for example, here I've got 3 sliders. Each of them is controlling this wind farm simulation, but each in a different way, using a different interaction technique. One of the things we tried is this touch slider here. So here I can just stick my finger in the slider and have it go to a particular value to control that wind speed there. It felt okay. We also tried this push slider. So this guy kind of nudged from side to side, kind of like an abacus, which was interesting. Now, the interaction that really took home the cake, though, was this pinch slider. The way that works is you just pinch it and move it wherever you want. And what we found was that people really like that tactile sensation of their fingers touching as they grabbed and released. And across the board, for all interactions, the audio and visual feedback as you grab, move, and then release were all really critical for making this experience feel connected.
So I'm going to pause it there. To be very, very clear, we have more HoloLens devices than we deserve, frankly, in our lab. And without them, we couldn't do the research that we do. So I am not sort of trying to bash Microsoft here at all, but I find this video compelling because this researcher starts off by saying, we spent years examining, right, this UI space, and right, here's the shining example. It's not a scroll bar, but it's like the horizontal version, right? It's a slider. It's a slider widget, and it looks exactly like the ones we have on desktops, but now they're like a meter long and floating in front of me. And I've got these large motor movements that I'm using to manipulate them. And, you know, I know what the newer versions look like of this, by the way. They're not this big. But I couldn't help to think, can't we do better than just grabbing the widgets from desktops or tablets and throwing them on planes around us? And one way to think about this is to deconstruct a little bit and say, well, what does, for example, a horizontal slider do? Why do you need one? And so one answer to that would be, well, the user needs to specify a value within a range. Well, are there other ways to do that? Are there other ways to do that that don't, you know, on desktop systems, right? You've got this mouse, you've got the pointer, you've got to carefully place it on the little widget, and you've got to move it. And luckily you can rest your wrist on a desk and you've got that affordance. Same thing with the touchpad, or sorry, a touch surface. You can put your finger on the surface, right? But now we're in AR, right? We're in free space. So maybe the slider that relied on careful mouse pointer positioning or careful touch positioning with the affordances of desks and surfaces, maybe this version of this specifying a value within a range isn't the best version. I mean, maybe it is. I don't really know, but I think these are interesting questions, and these are questions that the community can look at, right? So that's one of the reasons I shared this video. So can we do better, right? And how can we move forward? And so I'm just going to spend the next few bit talking about 3 different ways that we can think about AR interface design that will help us do better, I believe. Some of this is going to be, none of this is like Joe's novel insights on the world. These are my sort of observations gleaned from a collective set of great work in the community. So to be very clear, the first 2 items especially are things that folks know about. Maybe it will be new for some of you, and I hope it is. But the last part I think is really the kicker. Okay, so we'll get there. So just starting off really quick, if you hadn't read, you know, sort of an early paper by Billinghurst in '98 about screen relative, body relative, or world relative, like I think they used the term. They use a different term than relative, but these are different ways to think about placing AR information in the world. So instead of necessarily just putting our interface designs on these planes, we can think a little bit more creatively about, do we want to place information on the screen and lock it, but we're relative to our body or relative to the world? And do we want this to be static or animated? And their different information will shine, right, and result in a better user experience in different positions based on the task and the work at hand. So you have to think a little bit about where best to place information given the design problem. And lately I've been kind of thinking a little bit about this tool or object relative information, because this could be really powerful, right? And you could say, well, Joe, this tool relative thing is really just body relative, right? It's in your hand. Yeah, until I set it down, okay, and walk away from it. Okay, but then it's world relative. Or then, you know, maybe if I hand it to somebody else, it's somebody else's body relative. So, you know, but maybe it's still an interesting construct to think about when we're designing an AR interface and just trying to decide where the various elements should be placed. You know, of course, iteratively, you know, testing these things, but at first cut, thinking about where these types of information should be placed. So we have these frames of reference. They've been in the literature for a while. They're important to remember when we're thinking about holistic AR interface design, right? The answer isn't stick everything on a 2-dimensional bounded plane and then put that plane next to the user, let them put the plane wherever they want and then go. I don't believe that. Does it work? Sure, it works. We've been making interfaces like that in our lab. There are commercial ventures out there making interfaces like that. It'll work, but can we do better? Probably. Here's a little video that shows how information can move between spaces, which I think can be very powerful, different frames of reference, right? So this is obviously an automotive application with a head-up display. We've got screen fixed graphics on the bottom for the most part, but then we have these chevrons that are animated, and as you'll see, start off world relative, but then as we make the turn, kind of snap onto the screen, or in this case, car relative. They're almost synonymous in this particular use case. creating this kind of nice effect, and then with a little bit of animation, and almost going back into a world relative configuration at the end of the turn. These are the types, this is a type of thinking that I believe will allow us to create experiences that we don't currently have on desktops and tablets, and will be unique to AR and make AR really shine, right? This is what we want to do. So, and also, you know, effective performance and safe performance, of course. So moving between those frames of reference, also very important. The second thing, standards. And let me be clear here. I'm not talking about ISO standards, so I probably could have used a better word. These are guidelines. These are human interface guidelines that have been around for a while. And I'm not going to open the book on all these, don't worry. But Apple has led the way from the early years, and they still maintain a very good documentation, moving from not just the desktop space, but to the mobile space. And you know, these are really great, right? Because if you're a designer, remember we're talking about interface design. So we have all of our user requirements because we're good UXers, right? We know what the users need to do. We've kind of got some conceptual ideas, and now we need to kind of find the widgets to solve that provide that functionality, and widgets that we know we know the widgets already work. So we go into the interface guidelines. We've got this standardization. This works great. Okay, we need standards. We need human interface guidelines, and they're coming. They're coming. So if you haven't had a chance to look at these, this is actually a pretty interesting exercise. You can dig in to all of these companies' various augmented reality interface design guidelines, and you'll see some commonalities, and you'll also see some really interesting differences. And you'll see things like I'm talking about, where right design patterns of the past are simply brought forward, and you'll also see some really innovative design ideas. Okay, and another point here is that these are still emerging. Okay, so I don't believe it's too late yet. I guess maybe I'm an optimist. I know I'm an optimist, but when it comes to this particular problem, right? So we've got collaborators with these companies. We've got students that go off and work in these companies, right? Let's try to keep the conversation open to ensure that these standards are evolving and emerging in a way that really is going to create the kind of experiences that is going to make AR truly a next generation user experience, not a bunch of virtual tablet interfaces that surround me. Yeah, so we do keep an eye on these standards, but it's important, I think, to consider that even if we have these first two pieces I mentioned, right? Even if we have an understanding of where to put information, and even if we have standards that tell us, well, if you're going to do a slider, right, you want to use this kind of thing, right? Even if we have these human interface guidelines, there's another challenge or opportunity, rather, lurking that from a design standpoint, I don't have my head wrapped around yet, and but it seems really fascinating and hard. So, and this is, again, not a new space. This is a space that people have been working on, but I'm kind of coming at it from the design the design side. Oh, sorry. I'm skipping ahead. Let me back up. Yeah, most of you all have seen MRTK, so I don't think I need to bother here. I will point out one thing in here, and this is just Microsoft's versions, right? There are other companies' versions. There are techniques in here, right? Like the real-time movement of the labels to deconflict. These are ideas that came out of our community, right? So we have the chance to shape these. We have the opportunity to shape these design guidelines, and we don't just have to simply accept standards from the past, right? Okay, so, but the trains are leaving the station. The trains are leaving the station, and things are going to stick, right? The good and the bad, they're going to stick because they do, right? I mean, I literally went on to Office 365 2 days ago to see if there would be a floppy disk icon still, and yes, there is. And I would bet money there's going to be a floppy disk icon in the AR interface space. And that isn't to say that we shouldn't leverage people's mental models of various computing actions, right? So we can't just simply abandon, known symbology and invent our own new things. But on the other hand, we we have to be cognizant of what we're delivering, because some things are going to stick, good or bad. They're going to stick. And also, there'll be new technical capabilities that will arrive, hopefully ones that will disrupt. And maybe some of you guys up here in the audience and some of you at home are working on some of these new capabilities that will help disrupt the AR UI space. We'll see. We'll see. So, okay, right. So now, even if we know where to put information, right? So we can put it in the world, we can put it in the world, we can put it on a screen, we can put it at body relative or maybe tool relative, and we have these standards to help guide us. There's this kind of lurking challenge, right? I think the design rules are changing, and I think they're changing now, or very, very, very soon. And what do I mean by changing? Traditionally, UI designs were, the actual design, not the design effort, but the resulting designs. They're pretty much kind of fixed for different user roles, right? You create the best interface you can for that ticket seller, right? That's got to process all of the, back when you called in to Ticketmaster or whatever, right? Or, the ATMs that people use, or whatever phone app that you like to use. Those interfaces are relatively fixed. Now, are they responsive to different screen resolutions and aspect ratios? Sure, but they're basically fixed. And there's a process for this, right? The UX process says, hey, take these Legos, take these building blocks, arrange them in this way, package them up, and you're going to probably have a pretty intuitive or effective user experience for 80% of the population. Good job. We'll iterate and make it better next time, but it's still fixed. That's done. It's not done yet, but it's going to be done soon, I think. And instead, what's going to happen is not just in AR, but we're going to have interfaces that are going to adapt to all sorts of various contexts. They're going to need to be fluid. This is great. This is contextual interfaces is what I'm talking about, right? Contextual user interfaces. And the challenge is going to be, as a designer, is how do you account for all of the possible combinations that your system may encounter, all the different contexts or the arrangements of contextual elements, right? So if this interface is going to adapt to Joe, as Joe goes through his day, his week, his life, different environments, different tasks, different levels of fatigue, how do you design that for me and then for other people? And this is like it's like a multi-dimensional responsive design problem. And I think we have been and are still continuing to look at some of the pieces of this, which is really good and important work. But this kind of holistic perspective about how do you design for this is going to be very difficult. And now is the time. I think the time is now, right? This is like when the PC went mainstream, and it's not exactly there, but we're a little bit before that, because the convergence of maturing technologies is happening, right? So computer vision is going to be able to sense the space in front of me. It's going to be able to know, how well am I doing this particular task? Am I shaking today because I didn't get enough sleep, or because I'm getting older, or because I'm taking on, a new kind of ability, right? It's going to be able to sense any kind of tools or other spaces in my area. We've got all these wearable technologies that are going to be able to sense the user, right? What is my workload, right? Am I frustrated? Am I tired? What's my level of situational awareness, visual attention? And then we're going to have, sort of these cyber physical systems and IoT that are sensing the whole environment, a dynamic environment, and we're going to have to smash all that together using AI and then produce some really awesome user interface. And so the technical nuts and bolts of the computer vision and the machine learning, the IoT, cyber physical systems, the wearables, those things are maturing and they're coming together now. And the result are cool demonstrations. But the next logical step is, how do you design to afford to leverage all of that capability so that you really deliver an adaptive, context-aware AR user interface that hits the mark? And I don't know, that's a hard design problem, because it's more than just adding or removing user interface elements, in my opinion. It's much more nuanced than that. And we'll have to take into account all of these different, at least these 3 different contexts and more. And people are working on this, so that's good. That's good. Okay, so in kind of closing up here, what can we do, or what can you guys and all you all, right? What's kind of specific things can we do if we're interested in this space and we want to see it push forward? Couple of thoughts. We can continue to explore context-aware UIs. This is a great paper by Linda Bauer, Feit, and Otmar Hilligus from the 2019 WIST conference that is sensing a workload and removes interface elements in AR that are not critical to the primary task. That kind of work and work before that and new work from people that want to take on this work, we need to keep doing this because we need to start understanding what things do we need to detect, how are we going to detect them, and more importantly, what are the user interface parameters that are going to be the most sensitive to human performance and safety? Because like I said, we can just add information or take information away, right? That's this first thing, the amount of information, but the list goes on, right? What information to present? How should we present the information? What's the presentation style? What are the temporal, what's the timing on this, or spatial aspects? In this list, I don't even know this whole list, right? We need to figure out what this list is, figure out which parameters are most sensitive, and then we need to explore it and prioritize these so that we can begin to get our heads wrapped around how we're going to be able to design for these context-aware AR UIs. And so we could use help. Anyone that's really good at developing, protocols for, leveraging ML and AI quickly in user studies so that we can explore this space. That would be good to do. Also, we can engage in convergent research. And I know this is a big buzzword, but I put this out specifically because I've been involved in a couple of research projects lately that are truly convergent, and it really gave me an appreciation of what I view convergent research as, which is, it's not this, right? It's not, I sit in the room with somebody who's a computer vision expert and then an AI expert, and we kind of talk about how we can put our peanut butter and chocolate together and make a Reese's piece. No, it's not about how we can put things together. It's about coming to a shared understanding of a knowledge space that could not exist in any of the one disciplines alone. And when you get to that space, you can then truly innovate. And I hope that people want to engage in this convergent research around adaptive, more intelligent augmented reality user interfaces. We'll see. We could deconstruct the UI space. Something else we could do. Maybe if this has been done, please tell me, because I would like to see this. What are the most basic tasks that a user interface needs to support, right? We talked about specifying a range, a value within a range, a slider. What if we made a taxonomy of all these fundamental tasks that need to be supported? Of course, we can go back and look at how they were supported in other older platforms, but we can think about, well, does it make sense to migrate that widget into AR, or does it make sense to reconstruct the element in ways that like pay homage to successful UIs to date, but maybe also embrace what makes AR unique, right? And respects sort of ergonomics and human factors principles. So we could do this. And in fact, I bring this topic up, right? So for those old enough to remember, the early 3D UI community and Doug Bowman created a taxonomy of 3D user interaction techniques, right? 3D object manipulation, 3D object selection, right? Travel. That taxonomy spawned, decades of great work because it provided this roadmap of things to explore. I kind of feel like we could use a corollary to that in the kind of visual part of the interface space, and maybe it's out there and I'm not aware of it. So yeah, so we could do that. And then lastly, we can't forget, right? We cannot forget that the things that make AR unique, and we need to embrace them, right? We really need to remember the power and the promise, and not simply just, again, grab widgets, put them on a plane, stick the planes around us, and say that interface is good enough, because I know we can do better. I know we can do better. So yeah, so in that, I guess there's a vision, right? There's a lot of work to be done, and we live in exciting times. These elements, right? Mice, mouses, Mises, touchpads, keyboards, windows, or even our sliders. Maybe these don't apply as well as maybe we can do better, right? Maybe these don't apply. We have these things, right? We have these capabilities. That's the whole point of this discussion today, is that we have new technical capabilities that I don't believe we've fully utilized yet to create compelling user interfaces. We have, at a minimum, these things. Some of these question marks, right? These could be some of these sensing technologies I talked about, computer vision, right? Wearables to understand the user state. We have these pieces, these technological capabilities to really create the next generation of AR digital experiences. And so I guess my question to you all would be, now that the capabilities are here, what would your role be? What will your role be? And I hope that you'll find one. So thank you. I'll stop sharing my screen now. I promise I practiced and it wasn't an hour long. But
I think we may have, do you have a couple minutes for just a couple of questions?
of course.
Because I saw one, let me read it because it's long and figure out what parts of it I need to say before I say it. This is from Discord. Will AR user interfaces eventually converge on a few standards, or will they diverge as new AR user interfaces appear one after another simply because we have not fully explored the possibilities of AR so far? And a second question to that is, and this is from Kiyoshi, out of the 100% of the full potential of the AR user interface, how far do you think we have explored?
Can't you give me a softball question? Okay.
No.
The first question. I think we can look to the mobile phone space for analogies, right? So is an iOS interface on an iPhone the same as an Android interface? No, not exactly. Are many of the widgets very similar, and are there common symbologies used across them? Yes. So I think we will see divergence. This is opinion. I think we will see a lot of divergence as the field is finding its way. This is why I think we still have time to as researchers to provide input. But I do think we'll settle into, the major players are going to have their flavors, and I don't know how much they'll bend, right, after we settle in. And then as far as the second question, or Kiyoshi's question, right, how far have we settled in, right? How much of the space have we covered? I have no way. I have no idea. I have faith that as academicians, we can create the next generation of researchers that will go into industry and do their best. So I'm not the kind of person that thinks, oh, industries are big companies that push these awful interfaces on us, and us woe academicians can just critique them. I'm not of that camp. I think kind of we're all in this together. But I do think, though, that there will be a settling. I don't know when the settling will come, but I have a feeling it'll be within the next 5 to 10 years. And Missy, I just want to say, I know, Bobby, you have your hand up. There's a question here in the audience too, so maybe we can, if we have time, we can take both.
Yeah, I think we could take both, and then we'll have one from Discord, one from in person, and one from Zoom. And I feel like we'll have spanned the space. So do you want to get the one in person right now?
Okay, sure. This is from Jason Orlowski, I believe.
So I really like your talking about the history of doing and that seems like a really obvious example. I saw that you immediately everyone's interact. And by the 90s, everyone knew that this was a really good. We've been with augmented reality since the 1960s, so and we're in the 2020s now, but still there's no seemingly obvious like this is the way it should be. Do you have any ideas why that is?
Okay, so I'll repeat the question really quick for the audience at home. It was a great question, Jason. I'm not going to do it justice, but I'll do the short version. That in the historical example I gave with the visual interfaces, Steve Jobs came in and saw the graphical user interfaces, believed it would be the way forward, and it took however long until there was a couple of decades before there was mass penetration of graphical user interfaces. Ivan Sutherland's work, right, started in the 60s. We've been working on AR interfaces for a while. Why haven't we gotten farther along? And I think, Jason, I mean, my perspective is that, I mean, look at how much the hardware cost. I mean, I've got AR displays in the lab that aren't that old and cost, $50,000. I mean, that's just not accessible to the people that need to be accessible to anybody, really. So I think as the hardware becomes more pervasive, like I was saying with the VR space, as the hardware becomes more pervasive, we're going to get, right, we'll have a bigger tent. We're going to attract more and more folks from all sorts of disciplines and all sorts of perspectives. And we're going to get a lot of more creativity. Maybe that will help expedite, not expedite, maybe that will help mature the AR interface space. So, yeah,
All right, and before, oh, sorry, go ahead.
No, I was thanking Jason for his question.
Before I let Bobby ask his question, we are gonna have to move on after this, but please use the Discord and there will be more time to kind of discuss these kinds of things, and that's a great place for it if there's not time in the workshop. So Bobby, go ahead.
Hi, Joe, thanks, great talk. So my question for you is, you've treated, it's a kind of a riff on Kiyoshi's question a little bit, but you've treated AR as sort of a unified interface medium here, but is it really a unified interface medium? I mean, you have different types of displays. You have optical see-through, video see-through, you have mobile AR. Is there one unified standard for all of those things, or are we going to split into different AR? I'd like to hear your thoughts on that. And thanks again for the great talk.
No, thanks for the question, Bobby. That's a nice question. I hadn't thought about that, but I think, I mean, right. So there's going to be a split, right? Because I mean, as an easy example, the handheld AR space should leverage what we know about handheld phone designs and the affordances of that touch surface. I'm not sure, gesture-based interaction with phone-based AR makes as much sense as gesture-based interaction would make with head-worn AR. So that's that. Yeah, I need to think more about that, but I do think though there will be some splintering for sure. But I mean, actually, I'm going to one more thought. So, the web. I know I sound old with these examples, but the web design space recalibrated when the mobile interface design came along. Right? Think about like the little kebab menu or the hamburger menu, right? Those kind of started off on the phone as a need, because of lack of space, and then migrated over into the web space. So I think we'll see some cross-pollination across those different medium. But but it's a good point. I don't think they'll all necessarily be exactly the same. Looks like Rick's mobile. Like that.
Thanks everybody for the questions. And Joe, you'll have to get on Discord because there's some long ones and some good ones in there, but unfortunately we don't have time for that. So we're gonna have to shift gears a little bit.
Thanks
Yes,
again.
I have gone mobile because we are streaming PERCxR live at La Trobe University, and I wanted to avoid feedback, so I had to go kill the speakers. Thank you very much for that talk, Joe. I think that was really fascinating, and there are tons of questions. There will be more time to discuss this, not only in the Discord, but hopefully, Joe willing, in the breakout rooms and the Miro board sort of ideation session that we're going to be doing in a little bit, because we do specifically have one group that's going to be discussing the ideas that come out of today's talks. So please feel free to pop over there and harass Joe and his fellow speakers in the coming little bit. So we're running just a couple minutes behind. I think that's okay. We should still have plenty of time for everybody and everything we want to do. But with that, I'm going to pitch to our first speaker. So I see Holly is in the room. So Holly, I believe we said that you are up first. Holly is a PhD candidate in cognitive psychology at the University of Utah. She studies spatial perception and cognition in the real world and in mixed reality, and her current research focus is the perception of affordances in augmented and virtual reality. So her talk is going to be on information for the calibration of perceived action capabilities, the roles of feedback in virtual environments. And if you're able, go ahead and share your screen if you're there. I'll stop talking.
It says, I don't know if you can disable the screen share, or yeah, it says it needs to let me screen share. I need like permission.
I will make you a host, make you a co-host. I think that should let you do it.
I just changed it to all participants, so that might
Okay.
go faster. Nobody steal it, please. Hey, or we'll take it away.
Thank you very much.
All right. Okay, so it should be sharing. Is it sharing right now? I think it is. Yeah. Okay, one second here. All right. Well, yes, thank you for that introduction. Yeah, I'm Holly, and in today's presentation, I will be reviewing the effects of providing feedback on calibrating perception of action capabilities in the real world and mixed reality. So every day we make judgments about our ability to interact with the environment. Opportunities for action present in the environment that are based on one's body and capabilities are called affordances. In the real world, affordance judgments are usually accurate because they are calibrated or scaled to one's body. For example, you know that you can walk through a doorway without turning as long as that doorway is wider than your shoulder width. So we could say that your perception of passability through a doorway is calibrated to your shoulder width. However, sometimes our perception is inaccurate. For example, you might try carrying a large object through a doorway thinking that it will fit, but then it doesn't. And the situation is depicted in the Charlie Brown cartoon here. So in the real world, when you collide with a doorway, you receive sensory information that provides feedback about your ability to walk through an aperture. For example, you receive visual information about your body, the width of the doorway, and where you collided. You also receive haptic information when you feel the contact between your body and the wall. So when there is a change to one's capabilities or to the environment, perception needs to be calibrated to account for that change, and providing feedback facilitates that calibration. In addition, so mixed reality is a different environment from the real world, and it can alter users' capabilities for action. And several studies indicate that perception in mixed reality differs from the real world. For example, users underestimated their ability to step over a gap in AR compared to the real world. So providing feedback could help calibrate perception in mixed reality to resemble perception in the real world. This leads us to ask the question of how can we provide effective feedback for affordance perception calibration in mixed reality? There are limited sensory cues available in mixed reality compared to the real world, and this lack of information affects the ways that we can provide feedback. For example, if you walked into a virtual wall, you would not receive the same haptic feedback from the collision like you would in the real world, and it might be difficult to determine if you collided with the wall from visual cues alone. And this is shown in the clip here, which is from one of our prior experiments. And as you can see, due to the limited field of view, it's kind of hard to tell whether you collided with the walls or not. This can lead us to ask questions like, is haptic information necessary to calibrate perception in mixed reality? Or can the collision haptic information be substituted with different sensory cues, such as visual or auditory indicators? In order to understand what sensory information is important to provide in mixed reality, we can look to research on feedback and affordance calibration in the real world. Experiments in the real world have typically implemented two broad types of feedback: exploratory behavior and outcome feedback. Exploratory behavior is feedback that does not provide information about the outcome of the affordance judgment or action. Considering passability through a doorway, an observer would experience exploratory behavior feedback by simply standing and making judgments about whether they could walk through that doorway, but they never receive feedback about the accuracy of those judgments. However, just by standing, an observer receives sensory cues from postural sway, such as visual information about the relationships between one's height and objects in the environment, and proprioceptive cues like balance. Outcome feedback provides information on the accuracy of a judgment or action performance. And there are two types of outcome feedback: static outcome and action performance. In static outcome feedback, the observer makes an affordance judgment and receives feedback on the accuracy of that judgment without performing the action. So in our example here, the participant would make a judgment on whether they could walk through the door, and the experimenter would tell them if that was correct or not. In action performance, the participant executes the afforded action and consequently receives feedback about the success or failure of their performance. So again, in our example, the participant would actually attempt to walk through the door, and in doing so would realize whether that doorway was wide enough to let them pass through. So a large body of work examining feedback in the real world suggests that exploratory behavior is often able to calibrate affordance perception, although outcome feedback can be required in some instances. Research on general affordance perception and mixed reality is growing, but currently there are only a few studies that have specifically investigated the effects of providing feedback on affordance perception calibration. The studies that do exist have primarily focused on the affordances of reaching for an object and walking through an aperture. And these studies indicate that action performance can calibrate perception for these affordances in mixed reality, but other forms of feedback have not been thoroughly investigated. A unique feature of VR is that it allows us to manipulate visual body cues that would be difficult to do in the real world. So if affordance perception calibration in VR is dependent on seeing an avatar representation of oneself, this would imply that visual body cues are an important mechanism for affordance perception calibration. And some of the current research has started to explore these effects. So now I'm going to go a little bit more in depth on these existing mixed reality studies. In mixed reality, the effects of feedback on reachability perception have only been studied in VR. Action performance has been found to calibrate reaching judgments, meaning that receiving visual and perceptual motor information from performing the reaching action resulted in participants making judgments that were more accurate to their actual reaching ability. Recent work from our group found that only providing visual representation of the controllers during performance was sufficient for calibration to occur. A study in 2018 explicitly manipulated the amount of body representation and found that when only the controllers were visualized, reaching judgments were initially less accurate than the other conditions, but after receiving feedback from action performance, there were no differences. Another 2019 study manipulated participants' ability to reach by changing their arm length or using a tool in virtual reality. And here again, participants calibrated their reaching ability to their modified ability. Almost all VR studies have only used action performance feedback, but a recent study found that exploratory behavior was able to calibrate reaching judgments when posture was manipulated. So this means that participants were able to calibrate their perception by receiving cues from postural sway without needing feedback about the outcome of their judgments. Similar to the studies on reaching, a recent study examining passability in VR found that action performance was able to calibrate affordance perception when participants were asked to make judgments on whether they could walk through a doorway while holding the object. So after participants practiced walking through the virtual doorway with the object, their subsequent passability judgments became more accurate to their actual ability. In this experiment, they also manipulated the presence of a self-avatar and found that having the avatar facilitated the perceptual calibration. In AR, recent work from our group found that static outcome and action performance feedback calibrated passability judgments. However, the direction of calibration depended on the type of feedback. So when participants experienced static outcome feedback, affordance perception became closer to participants' actual ability, meaning that their judgments of passable apertures became closer to their shoulder width. However, when participants physically walked through the virtual aperture, they subsequently perceived that they needed wider doorways to pass through. We think that this finding might be due to the difficulty of perceiving visual information about the width of the doorway and whether or not a collision occurred during passage. Taken together, the results of the existing research suggest that having access to visual body cues during action performance can facilitate the calibration process, at least in virtual reality, but they are not necessary for calibration to occur. Additionally, ambiguous visual information affected the direction of calibration in AR, so static outcome and action performance feedback might produce different results in mixed reality. Given the limited existing research, it is still an open question as to what types of feedback should be used in mixed reality. Future work should include different types of feedback within the same experiment in order to better understand what sensory cues are necessary for affordance perception calibration. Future studies should also examine perception calibration for different affordances, since the existing work has only used affordances for passability and reachability in the context of providing feedback. Another interesting open question is whether the type of feedback affects the transfer of affordance perception calibration. For example, if feedback calibrates perception for one affordance, does that transfer to another affordance? And if feedback calibrates perception in a virtual environment, does calibration generalize to the real world? The results of these future experiments can help us understand the informational variables underlying affordance perception. If affordance perception can be calibrated with some forms of feedback, but not others, this would indicate that which sensory cues are necessary. For example, if static outcome feedback is sufficient to calibrate passability judgments, this suggests that the perceptual motor feedback from physically walking through an aperture is not required for calibration to occur. Additionally, it is important to understand how affordance perception can be calibrated in mixed reality, because the technology is increasingly being used for training and education purposes, and the effectiveness of these applications depends on whether viewers perceive and act in mixed reality similarly to the real world. Thank you all for listening, and I'm happy to discuss these ideas more and answer any questions or comments.
Thank you very much, Holly. I think that was a really great talk. We have time for one or two questions before we move on to our next speaker. And I see that Saab has his hand up, so please take it away.
Thank you so much for that great talk. And it's wonderful to see a lot of the great work that you have cited here, including some from my students. So when we did the work with that you cited on Ayush Bhargava, and when we did the work with Eli Ibrahimi, one of the ways by which we made sure that participants had feedback of their embodiment in virtual reality as they were performing these tasks were to have a mirror in that environment, so that they can see their extent of their self-avatar in situations in which it was manipulated, or if it was matched to the body scale of the user as they were reaching or performing these tasks in the near field. So I think that mirror actually facilitated a lot of feedback that they had in the static situation, or perhaps in the, I forget the terminology that you used, in the situation in which they are enacting and getting affordance, getting feedback through actually performing those actions with those apertures. So I think that there's a lot to be said about that mirror and the feedback that it provides. And I do not know if such feedback can be incorporated in augmented reality situations. So I would love to hear your thoughts on that. And additionally, we also feel that due to the limited viewing capabilities of the head-mounted display, sometimes participants may not notice the overlap or the intersection between their self-avatar and objects in the environment. In that case, I'm curious to also know what thoughts you may have with regards to how we can provide that rich feedback to users so that they can then recalibrate their actions.
Yeah, all great points. I like the mirror aspect is something that I thought was really unique about your guys' studies, because like you said, like in the picture here, it allows them to see themselves, and like it allows them to see the aperture as well. So it's like as you're walking toward the doorway, you can see like in your reflection where you are in relation to that doorway as well, which probably helps like keep you centered through the doorway and such. And so I also liked in this experiment where you have like the visual cues of like you highlighted the wall if they collided with it. So I think these are all great ways that could supplement feedback for calibrating the affordances. Like you said, it is an interesting question about trying to provide that in AR, and it's something we have thought about just because, especially in AR with that limited field of view, and when people walked through the doorway, it was really hard to keep them like centered as they walk through, because you can't really tell where you're walking when you get so close. So yeah, definitely something to consider. And yeah, I mean, I'm not really sure how we would be able to provide that in AR, but I do think it's a very cool manipulation, or like an aspect to provide in VR when you can.
Thank you. Nice talk.
Thanks.
Great. Thank you very much, Holly. And I see another hand from Daniel, but could you, is it a quick one?
Probably.
Okay, let's do one more and then we'll transition to our next speaker. Thank you.
Just to know if there's any studies that are trying to use not just the self-perception of body as a feedback. For example, in gaming or in another experience, you use something more surrealistic, such as show a green or a red thing and how the user perceive it as affordance to cross or not. Or if there's any studies using this type of cue, like more surrealistic or more like digital cue to say somehow, and how the user perceive it. I'm not sure if you tried that or if this is existing in the current literature.
Yeah, some recent research with mobile AR, actually by our next speaker, has worked on that a bit, but they provided some like additional visual cues. So like for walking through an aperture and for stepping over a gap, that might help, whether people's judgments would improve with those. And I can't remember which one it was for, but for one affordance, it did help. And for the other affordance, it didn't really help. So that is another way we could provide feedback, and especially in AR where you can highlight like different objects in the environment, those might be useful cues for calibrating actions.
Thank you.
All right, thank you very much. And thanks once again to Holly for an excellent talk. If you have further questions, I hope that she'll stick around for the discussion session and you can ask her anything you want at that point. But with that, we're going to transition to our next speaker. And our next speaker is Brooke Zhao, who is a PhD student of computer science at Vanderbilt University. Her research focuses on understanding how mixed reality technology impacts human spatial cognition and how to effectively leverage that technology to enhance people's spatial learning. The title of her talk is Investigating Augmented Reality Spatial Perception via Handheld Mobile Devices in a Distributed Experimental Setup. And with that, hopefully you can take it away.
Can you see my screen? Okay. Hi, I'm Brooke from Vanderbilt University, discussing our experience in conducting remote AR spatial perception experiments in this talk. As we know, XR research usually takes place in a controlled lab setting. There has been little research into remote distributed XR experiment. Now, what I mean for remote research here is when we do an experiment with some behavior measurement, participants are not directly under the supervision of the experimenters. They do the experiment in their locale with their own hardware, and experimenters retrieve data remotely. In the past 2 years during the pandemic, we can see some efforts on identifying the drawback and opportunities of remote XR research and give us a picture of who the VR headset owners are. A few studies have explicitly attempted to replicate lab-based research using a remote sample of participants who own their own VR equipment. If they replicate the findings, the answers are mixed, with some findings replicating and others not. Besides, we can also see some demographic differences between participants of remote VR studies and lab-based studies in terms of gender, spatial ability, and video game experience. So how should we report and sync up the different samples and findings in distributed experiments? Should the distributed setup be considered as a valuable asset for XR researchers even after the pandemic? We are still at the outside for these questions and need to learn more about the different characteristics of remote XR experiment compared to lab setting to answer these questions. So in my presentation today, I'd like to talk about the challenges in our remote experiments and what we learned from them to inform the design and development of future remote XR studies. Our experiment, different from most of studies I just mentioned that are conducted in virtual reality, we conducted 2 augmented reality experiments for assessing AR spatial perception via handheld mobile devices in the remote distributed experimental setup. The first experiment is an affordance judgment experiment, like just in Holly's talk. We investigated 2 judgments of action capabilities with virtual objects presented through smartphones. They're passing through an aperture and stepping over a gap. The second experiment is a distance estimation study. We evaluated whether social cues affect egocentric distance judgments of a virtual human avatar. We developed our applications by Unity and use AR foundations to support AR features in AR Core for Android devices and ARKit for iOS, and deploy the apps for both experiments on Google Play and Apple App Store to assess our participants. But there are some problems for deploying in App Store for one of the experiments. In the second experiment, it contains masking social cue. So the Apple App Store found it was indirectly related to the pandemic. It was not accepted. Therefore, we finally chose to use a testing version for participant recruitment. Our first note here is that a published version requires additional review by the App Store. The content in the experiment of our interest might be sensitive for publication for running remotely. So always prepare more time for deploying the software remote experiments. Besides, consider the compatibility of applications on different devices and different operating systems. More efforts are required for testing the robustness of the software compared to lab setting experiment. The high prevalence of smartphones makes recruiting participants to run our remote applications feasible in terms of hardware accessibility. We recruited 32 participants. The distributed setup allows for more heterogeneous population in terms of age range and region compared to lab setting, in which most participants are university students. In the remote experimental design, one main challenge is that the experiments are unsupervised, resulting in the loss of interaction between participants and experimenters. We know people prefer illustration compared to reading a long paragraph, so we try to make use of the refined graphical user interface and more visualization to provide more straightforward and clearer instructions. Besides, one of the rules of our remote protocol design was to keep the number of tries to as few as possible. We were concerned that people would be less committed or become fatigued if there were too many repeated trials, which will likely influence the results of the experiments. In addition, think carefully about the reliability of your collected data. For example, in our first experiment, self-body dimension measurement was necessary. What we did was, at first, we showed a photograph illustrating the procedure people should follow and set a default value for participants who could not find a tape measure at hand. Second, after we got the data, we compared the measured body size in the remote study to previous affordance judgment work in our lab setting to further check the quality of the measurement. One thing we could do, but we didn't think to do, is we can ask people to take a picture when they're measuring their body, so we can check whether people actually follow the measurement procedure and maybe potentially extract the measurement information by computer vision techniques. From here, we learned that due to the higher uncertainty and variance and remote sighting, it's important to log some extra data that will be helpful for validating the collected data of our interest and identifying and excluding bad actors or erroneous data. For data collection, we found that email service is a reliable choice for data retrieving if the file size is not too large and there's no sensitive information. To ensure the robustness of our data retrieval, we use Google Form to save data when there was an exception to the email process. Based on our experiments, we recommend enabling automatic data sending in our software to reduce the stress of participants. Yeah, another thing to be mentioned, it's vital to consider the privacy issue when conducting remote study. We got approval of a digital consent form for running study and collecting data remotely from our university's institutional review board. And we put a link by using an online survey platform, Qualtrics, for the consent form in our applications. So people can click that link to go through it and click yes to approve for participation. And we can ensure we got the consent before people start to run the experiment remotely. Overall, it is without question that remote XR studies come with some limitations, but they also open the door towards various benefits. Like in our experiment, testing participants in the wild across varying environments and with different devices provide us with more ecological validity, but with a trade-off of experimental control in measurements and context, even though we've carefully designed our experimental protocol. We think this trade-off was warranted in our case, given that AR apps in mobile phone are already in use in numerous contexts and will continue to be widely employed moving forward. But how to balance these trade-offs and enhance the remote setup and different types of XR experiments using different hardware for different research aims require more explorations and empirical experiments for our community. And finally, I'd like to thank my co-authors and the support of Office of Naval Research, and thank you for listening.
Am I echoing? I might be echoing.
You're not echoing.
Oh, okay. Sorry. I don't know what's happening, but anyway, hello. And does anyone have any questions? Yes, Daniel, go ahead.
I'm wondering, I'm also trying to conduct some remote studies, and I'm facing the issue of the people cheating in the forums somehow, or people just trying to make robust the system to the people cheating on your own experiment. What is your experience about this part, like that you really have this lack of control, right? And I don't know, what were your thoughts about this remote thing? And for me, I'm very worried about it, so that's what I'm asking.
Yeah. This might be a question, but in our experiment, we design, as I mentioned, we designed a quite short experiment, try to avoid lots of repeated trials. So that might be helpful for the question you just brought up. And I think another way, maybe the gamification of your experiment in remote sighting might also be helpful. Also, like you said, if you know they're cheating, that means you kind of have a way to validate they're cheating. So that may other way, when you pre-processing your data, you can tell when and whether they're cheating, right?
Just a little follow-up question is, If you don't have this data to validate, you have data from the lab and also data from remote study. What do you think, if you don't have this data from the lab, what do you think it might be the difference, or what it was the difference actually, in if you find any differences, or if you don't have one, for example, in the lab, do you will really rely on this?
So you mean you don't have a previous study, related study?
For example,
for your
if
validation?
your advice is always rely on have a backup of data that was conducted in a lab, or that we should always do that just to make sure something, or we can actually rely more on remote studies. Not sure what are your thoughts about.
Yeah, I'm thinking we actually have less control in the remote studying. There's more noise in data, but in other words, it may give us more ecological validity. So maybe that's the truth, or the direction we really want, or we really pursue, right? We may have more heterogeneous populations. It might got the actual users we really want.
All right, thank you very much for that. And as before, please, if there are any further questions or discussion, please feel free to put it in the Discord, or to put it in the Miro or the breakout rooms in just about half an hour. But for now, thank you once again to our speaker, to Brooke, on an excellent talk. And I am about to very happily pass it over to someone I am going to see speak live here in Melbourne in the same room as me, which is very exciting. So our next speaker is going to be John Power, artist and lecturer from Royal Melbourne Institute of Technology. And John is an artist and lecturer who uses both traditional and digital techniques to create still and time-based images. He has worked in scenic art and design, in TV, film, museum, opera, ballet, theater, and private commissions, which is a very interesting life. And I'm not even done yet. He has created digital FX and animation for TV, worked as an art director, and toured internationally and nationally as a VJ. He recently completed his PhD at RMIT University in Melbourne, and is going to be giving a talk on designing extended reality to support the periphery of attention in shared public spaces and health contexts. And I'll stop talking. Thank you very much.
Great. Thank you very much, Rick. Sorry about the too long bio. I'll send a one-sentence one next time. Hi, everyone. It's great to be here to present. I'm going to start off just to introduce the work that I'm talking about by sharing a video. So if I share, Rick, we'd be good to go with the audio?
We should be.
Let's give it a go. This is about 5 minutes.
Maybe not, I'm not hearing anything.
Let me just...
You have to share with audio.
Let me just interrupt that and try one more time.
Which is a different button.
In advanced sharing options, different button, share screen. Let's try again. Share sound. So sorry. Take two.
Locus amenus, place of delight, or just locus, is an ambient audiovisual installation situated in the public sanctuary lounge on the ground floor of the Victorian Comprehensive Cancer Centre, a purpose-built clinical care and research facility in Parkville, Victoria, about a mile from the urban centre of Melbourne. The sanctuary lounge adjoins the Super 8 Cafe, owned and run by Potter and Billy Sakis. The locus installation is comprised of a 4.8 by 2 metre video wall and a surround sound system incorporated into the lounge area. The video wall depicts a window-like view onto a natural scene. The view of the scene is sometimes roving, sometimes resting, and perpetually animated by the weather. The terrains, ecologies, and plants depicted in the landscape refer to native regions of Victoria. The naturalistic sound components incorporate environmental and fauna sounds, also native to Victoria. Locus was conceived to foster calm, focus, and placemaking for the general public. The artwork is driven by local real-time data from the Bureau of Meteorology to represent the local weather through wind, rain, cloud cover, and the natural passage of diurnal light from a virtual sun that is synchronised to the geolocation of the hospital site itself, meaning that the virtual sun follows the arc of the sun outside, rising and setting at the same time. The endless real-time navigation and motion of the sequence is driven by computer algorithms. The gentle rates of change in image and sound are designed to operate in the periphery of attention so as not to distract. This gentleness allows those nearby to experience the work as an ambient part of the environment. The work aims to afford effortless and pleasant aesthetic encounter for those who electively attend to it to sit and look at the view, and at the same time, it should support the periphery of attention for those attending to other things, rather than distract. Locus uses multi-sensory ambient cues to give workers, visitors, and patients a sense of the passage of the day outside. Locus has been created and researched as part of a PhD project. Ethnographic fieldwork and analysis was used to study the ways members of the public respond to and use the installation. This fieldwork was done in a restaging of the installation at State Library Victoria, Melbourne's main metropolitan public library. This research was done to investigate how generative ambient public screens could be applied as a calm technology in public space. Calm technology is a set of design principles that aim to present information channels in ways that treat attention humanely and not cause distraction. Locus was found to fulfill the criteria of a calm technology application by transmitting meaningful information channels about the local environment that can be absorbed pre-attentively. In keeping with the principles of calm technology, this empowers the periphery of attention and fulfills the advice from calm technology researcher Amber Case that such applications be elegant, humane, and unobtrusive. In the process of this research, Locus has shown that an unobtrusive calm application need be neither minimal nor invisible, but rather can be appropriated by the public as aesthetic experience. In consideration of the aesthetic experience of the images, sounds, and movement in the naturalistic scene, this research has also taken into consideration the effects of biophilic patterns. Biophilic patterns are proposed as being emergent patterns in natural environments that support human attention, emotion, and flourishing. In considering ways that public ambient screens can be used to support calm and placemaking, I have linked a range of ways in which calm and placemaking can be supported by biophilic patterns. The combination of gentle, indeterminate signals and biophilic patterns can be applied to public screens as a way of developing calm applications that support attention and public placemaking.
Okay, now I'll share my slides. You could hear that okay? Cool, cool. Can you hear me? Great. Thanks again, Rick, for the introduction. So the generative data-driven approach in the work led to the iterative adjustment of variables that enabled the variation within the artwork to sit within aesthetic constraints that were tuned to the space. So it was interesting in a public setting being able to sort of do a live tweaking over weeks and months. Generative approaches to VR are being applied in art installations, game art, and as architectural augmentation. These approaches allow VR to create open-ended spaces, create ambience and create atmosphere in public space. This demonstrates the special qualities of real-time generative VR that make it particularly adaptable to enduring mediated works, creating a sense of immediacy and presence in the augmentation of a sense of place. Now, to calm technology, calm technology was first theorized in the mid-1990s, as many of you may know, as an approach to interface design that treated attention in a humane way by supporting the periphery of attention. For this reason, principles of calm technology were taken from anthropologist Amber Case, that reappraised the initial proposition of calm technology by Weiser and Brown with the benefit of historical hindsight of the rise of ubiquitous computing. I've used Case's principles as a way to uncover how a shared calm application can be developed for the humane treatment of attention in the shared social context of public space. I won't go through I won't read through the 8. Suffice to say that these are sort of contemporary principles that incorporate what we know since the rise of social media and other kind of distractive influences in our environment that can perhaps lead us back to calm interface solutions. My creative project works with the idea of an interface that can provide rich affordances for indeterminate appropriation, and is available to ambient awareness when it is needed, while essentially being ignored, much like being in a garden. Minimal attention here does not preclude rich environmental cues for rich embodied experience or even delight, but rather means empowering the user to get to their goal with the least amount of attention. Now to biophilic patterns, just quickly. Again, I won't read through this list, but there were 2 sets of biophilic elements in patterns. This is from Calabresi and Dommert, and intuitively, we can understand these: light, air, water, plants, animals, weather, natural landscapes and ecosystems, and so on. And on the other side of the chart, where there are sort of aspects of the feeling of being and moving through natural space. Since prehistory, a myriad of human practices have been motivated by the belief that living in harmonious proximity with nature is beneficial to human flourishing. Biologist and writer Edward Wilson's biophilia hypothesis proposed that the human drive to be in and around nature is an evolutionary adaptation towards survival, physical and perceptual development, and fulfillment of emotional, social, and spiritual potential. Where architectural approaches reach their limit, generative VR and XR screens can be readily adapted and modulated to introduce biophilic patterns into built space. And I'd make a note that places like state libraries and cancer hospitals, places where plants and living material is actually forbidden. You can't take plants into these spaces. This project shows how VR screens can adaptively bring a shared and responsive sense of the outside to the inside. I'm running out of time. There's the Ryan patterns as well that talk about biomorphic forms, but I'll draw attention to the right-hand column. These perceptual sense of prospect, refuge, mystery, risk and peril, and these aesthetic elements that can be worked into this enduring VR sense of a view out of a window. People find quite reassuring and restoring. So this is a slice of some of the elements that were used that supported the VR. So a kind of holistic approach to the installation. And I'm reaching 10 minutes, so I'll skip ahead just to make some final remarks. That the installation used a VR application to make an aesthetically attractive setting that supported orientation and locale. It supported the periphery and habituation. By habituation, I mean familiarity. It transmitted useful and relevant information channels about what was happening in the day outside. It made aesthetic and kinesthetic uses of generative VR to calmly enliven the periphery within an ambient threshold. It used calm and biophilic patterns to provide affordance for repose, dwelling, reassurance, and attention restoration. And I found that generative ambient public VR screens can provide a shareable social amenity to foster a humane sense of place. Thank you very much for your time.
You can hear me live, but you know, I'll clap here as well. Thank you very much for that presentation, and I think it was really great because I think that this brings a perspective that is not usually heard at IEEE VR. Right, in the sense that, you know, VR is not solely the realm of technologists and engineers, but, you know, also artists and users. So I think that was a really great perspective, and I appreciate it. We do have a hand up, and it is from Saab Babu once again. So Saab, please go ahead.
Thank you. Great virtual scenery. It's stunning. Are you planning to measure, for instance, your visitors' reactions? Perhaps, you know, if possible, their behavioral reactions, maybe through sensors, physiological reactions, because I can see this being rich in terms of human factors data.
Sorry, we got a bit of feedback.
I was too slow in the button.
That's a really good question, Sabah, and I would love to. In fact, I'd like to, at this conference, kind of reach out to collaborators. We did an ethnographic survey, and it took in remote observation of about 1,200 members of the public. So it was kind of opportunistic. And I did semi-structured interviews with about 88 people over 2 weeks. So that was and then used grounded theory methods to kind of analyze those. But to your question, that's where I'd like to move the research to next. So I'm really happy to connect at this conference because I see that as the next step.
Awesome. Thank you very much. I think once again, in the interests of time, we will move forward. But once again, the Discord is available. The Miro board is available. We're going to be having discussion in just a couple of minutes. But before that, we do have one more speaker. Last but certainly not least, we are going to have a presentation from Billy Van, who's a PhD student in the Informatics, Cobots, and Intelligent Construction Lab at the University of Florida. He started off his professional life as a biological scientist, designing medical devices and conducting clinical research in pulmonary medicine and neurophysiology, but he is currently investigating human-centered design approaches of assistive robots and virtual reality training methods. And his presentation is titled Sensory Manipulation as a Countermeasure to Robot Teleoperation Delays. If you're there, Billy, please feel free to take it away.
Give me 1 second. I'm trying to get the PowerPoint to come up. All right. Does it look like the slides coming up for everybody?
Mm-hmm.
Okay, great. So yeah, I'm a PhD student in civil engineering at UF, and it's a pleasure to share our project titled Sensory Manipulation as a Countermeasure to Teleoperation Delays. So this is just a very brief background and outline of that I'm going to share today with you guys. And first, I'm going to go cover just an introduction and background of our project, and then I'm going to walk you through a quick case study that I'll cover the methods and results of the study and some of the first conclusions that we have. And so to start things off, my advisor, Dr. Eric Du, he asked me to lead this clinical study involving teleoperation of a virtual robot to perform a teleoperation grasping and placing task. And so this study was funded through NASA, and we started developing our VR models and just the project overall about a year ago. And so the main takeaway with this slide here is that can we effectively provide people with a haptic interface so that they can intuitively control a virtual robot, essentially? And so the applications that we see stemming from this research could be this could be applied to controlling a robot in space, potentially even robotic surgery, and there's definitely other applications that we see this contributing to, other industries, manufacturing, but the main thing is that we're at this excitement today of potentially having a robot just replace a human, and in the sense that basically preventing harmful exposure of an environment to a person. And so this is just a photo of the virtual robot that we the virtual simulator that we have, that and this simulation allows us to manipulate the time delay of visual and haptic feedback. And so when a user is controlling this haptic interface, this is what we're using as the interface to control the virtual robot. And so we've also in the lab, we were able to develop a way to control the actual robot in parallel with the virtual. And so to give you just a quick visual, let me just play this for you. So that video just was just a demonstration of showing just what it looks like when a person can control the virtual robot, and like while we're in the development process of the virtual model. And the figure to the left is just a camera view of the actual robot that was being controlled as well. So to jump to just the overall study that we conducted, there was a total of 31 subjects that I collected from, and I asked everybody to perform a virtual pick and place task. And every subject went through a total of 10 trials. And at the very beginning, at the very end of each trial, I asked subjects to to give me their assessment of what they thought was their visual delay and what they thought was their haptic delay. And so the control for the study was just real-time visual and haptic feedback. And the 3 latency delays were 1/4 of a second, 1/2 a second, and 3/4 of a second. And we looked at 3 different, sorry for my background noise, there's a dog barking, but trying to do this without being distracted from that. But anyway, the manipulation strategies. So we have a total of 3 manipulation strategies in the study. And the first one is the asynchronized, and asynchronization is just when haptic feedback is provided at an earlier time than visual feedback. And so you could see that the gap in between the visual, when the visual feedback was provided, when the haptic feedback was provided, that gap is in reference to one of the visual delays. And the synchronization condition was is just when haptic and visual feedback are provided at the same time. The anchoring strategy involves just haptic feedback being provided real time. And the visual delay would be at one of those latency delays. And so with the results that we have, the visual perceived error is that's what a person perceives as their visual error, or not their visual error, is what a person perceives as what the visual delay is. And I subtracted the actual visual delay of what the conditions were from what they reported. And the results here show that the anchoring strategy provided, the anchoring strategy showed the overall lowest mean visual error in their perception. And anything, you can see that there's a dotted line at 0. And so anything below this dotted line indicates when a person perceived a lower amount of visual delay than what they were actually exposed to. And that's actually what we want to see. So what that means is we're actually able to reduce a person's perception of what they thought was their visual delay compared to like what the actual visual delay was. And so continuing on, so the conclusions that we're leaning towards are that perceived visual error was highly dependent on the strategy, and the anchoring strategy would be potentially is the most feasible to apply because not only does it show an overall low mean of visual error, but there's quite a bit of cases where we were actually able to reduce a person's perception of the visual delay overall with the anchoring strategy compared to the other strategies. And so the negative perceived visual error, which I mentioned, that's below the dotted line, that's what we interpret as a lower perception of visual delay. And now this big visual here is just showing the trade-offs of the visual and haptic delay perceptions. And so the perceived visual error, so in the y-axis is just showing the amount of error that a person has with their perception of the delay. And so if a person had no error, then they would give the response would be scored at 0. Because if, say, for instance, there was an actual 2-second delay and they reported a 2-second delay of their visual, well, then they would have been scored at a 0. But on this scale, this is showing the amount of error. So it's the difference that they reported versus what the actual conditions were. And so the red line here is the control. And so this showed the overall like lowest amount of error involved with the visual perception as well as haptic perception. But if you look at the other conditions, so the anchoring strategy, which is in green, showed the lowest visual error compared to the haptic, and then the trade-off with the visual and the haptic, you can see that this is just what we think. It just could be a part of human nature of where these are just the trade-offs that we're starting to see. I mean, we only have a sample size of 30 people, but we're hoping to collect more and see if these results hold up. The visuomotor error is just referring to the error in the gap between visual and haptic feedback. Now, yeah, if you guys have any questions, feel free to let me know.
Thank you very much for an excellent presentation. Does anyone have any questions for our final speaker of the day? If I don't see anyone else, but I'm happy to go ahead and offer a first one. So I think this is really interesting work looking at sort of the effects of delay on teleoperation, because that's perhaps an increasingly real problem. Can you tell us what are like I know you said that the latencies were, I think, 250 milliseconds, 500 and 750. Is that correct, or something along those lines? What is the scale of those latencies compared to something that you might see? You know, is this on the other side of the world? Is this in low Earth orbit? Is this, you know, on Jupiter? Do you have some sense of what we're looking at?
Yeah, that's a good question. Of what is like a real world scenario of what these latency delays would translate into? And I actually do not know, but we had to pick values that we needed to start somewhere with the visual delay and haptic delay with a choice of delays. But if we formed a study with something too long, like say 30 seconds of a delay, then we probably weren't going to have any useful results with that. And so we started somewhere with a manageable range of delay. And but in regards to like signal transferring from a robot to the operator, visual feedback, like if it's a video even, that's really, it depends on a lot of things. I guess it depends on the type of hardware they're using, and I guess if there's any barriers weather-wise in between the operator and the robot they're trying to control. It's hard to really say though what I guess.
Yeah, I mean, that's totally understandable. I was just curious because I think that would also be something that is probably worth looking into a little bit, because it's possible that that you're working with NASA or you know, putting forward this scenario of working with NASA at least, and you know, they might very well care what it's like if latency is 2 seconds or 5 seconds or 30 seconds, like you said. I mean, depending on what sort of scale we're dealing with here. I don't know enough about, you know, transmission delays on that scale, but I think it would be important for some scenarios. It would be important to investigate that. So, you know, just a thought. If there's no one else, once again, Discord, once again, the breakout rooms, but I am going to transition us to that phase right now. So I have thank you once again to all of our speakers, to Joe, to Holly, to Brooke, to Billy, and to John. Thank you all very much. But yes, the final phase today for the next half hour or so will be to go to the Miro board. The link should be in the chat. I will post it again in just a minute, and join a breakout room depending on what topic or topics you're most interested in. We're going to form sort of group discussions and just have a chat about the issues of the day. So we have 5 boards. You can go to whichever one is most interesting to you. We're not going to force it. One is on perceptual challenges for mixed reality, the biggest perceptual challenges that need to be solved. One is on the cognitive influences of mixed reality technology on cognition. One is on today's talks. One is on the sort of future of research in this area. And the final board is on the future of the PERCxR workshop itself. If you have any thoughts or ideas about what we should be doing, perhaps as soon as this October. So please feel free to jump over there. We, the organizers, will bounce among these panels and make sure that everything is sort of going smoothly. But please jump over to whatever you find interesting, and we will reconvene here. The breakout rooms will end at, roughly in roughly 32 minutes from now. I don't know what time it is where you are. I barely know what time it is where I am, but we'll spend this time for discussion, and then we'll spend 15 minutes sort of recapping that discussion and thanking you for your time. So see y'all in the breakouts.
Yeah, Mary, if you do have the name of the person you're thinking of, I'm happy to look them up too.
Are you thinking of Darkin's work, Mary?
Okay.
Yeah, we know about that.
Yeah, you know that. Oh, you're muted.
How do you spell that? Is it Darkin?
Ken.
Oh, yeah.
Ken. Rick, do you think it would be too extreme to close all the rooms and force everyone to come back here?
I think that is exactly what we should do. I was going to do it at X50. So I think you're
Okay.
exactly on the right track. We have
will
they have
wait.
1 more minute to wrap up their conversation.
All right.
Yeah, Missy, we get used to doing that when we're teaching online classes. Just bring everyone back, right?
Yep. Yeah, I haven't done a lot with Zoom. And I think when I was doing stuff with Zoom, it didn't have as many features. It was not as good as it is now.
Yeah.
There has been some growth. All right, I'm doing it. Oh, I should have done it a minute ago because they get a minute to do it.
They get a notice, and so that most of them will exit.
Okay.
How is everybody? There are some of you here that I haven't had a chance to say hello to yet. So hello, I hope you're doing well today.
I think I'm giving the workshops after this one a miss. I will tell you now. I went to VHCIE before, but I think I'm workshopped out for today.
Does anybody know how the Metaverse Foundations one is going to be run? What to expect? Because it runs awfully late, being how as it's already 8 at night.
At least we're not in Europe, right? If for
We're
anyone
not
who's
in
in
Europe.
The Europeans are doing it tough this year. It's their turn to.
It's their turn.
Well, it's only fair, Rick, since they got to have all the conference chair committee meetings at like 2 o'clock in the afternoon.
And what time was that for you, Rick?
I think they were mostly at midnight. So, you know, it could have been worse, but it wasn't great.
True. Yeah.
It was 5 for Sarah, I think. Is that right, Sarah?
Yeah, 6 for you, 5 for me.
6 for me, 4 for Amala.
Yeah,
I hope you don't mean in the morning.
In the morning.
Yes, we do mean in the morning.
Like every week for many weeks.
Brutal.
All right. I Is everybody back? I don't know if everyone is back, but I think let's talk to whoever's here. So thank you all very much for participating in the workshop, for providing your feedback, for participating in the breakout rooms and the Miro board. Hopefully you found it interesting and useful. I really enjoyed today's session, so I hope you did too. I think just to wrap up is I didn't actually do much Miro boarding. I just met a new friend who is perhaps not here anymore, Andres, who was oh, there you are. I didn't recognize you without your background, but but we were in the future of XR room, and we were talking about the sort of implications of philosophy on measuring perception. And I think that is very much the future of XR, but we didn't come up with any stickies to put on the board about it. Would anybody else like to share your thoughts or experiences from the breakout rooms? Or we can all just take a break and I'll send an email with the stuff from the Miro board later.
So Rick, you know me, the hardware engineer, and I said this in the group, but I would be really interested to know how and if improvements in what improvements in the hardware would make perception and cognition better so that it would all be more effective. Is that a standard question for me or what?
Yes, but that doesn't make it wrong, right? I think that this is all, it's moving the discussion of, one step upstream maybe, right? Where most, which is not invalid, right? I'm not trying to make that implication at all.
No,
like
no,
most
no,
we
it's just,
deal with what exists and make measurements about it. But we should, in a perfect world, we would have an upstream connection where we could say this is the problem that exists in current hardware and software. What can be done about it? I think that's a very insightful comment. Thank you.
so is one of your issues what to do about this meeting? Was that one of the topics? And maybe that's an easy one to do offline by email and all.
Yes, but that was one of the questions. So one of the questions it was, should PERCxR remain once a year, or is there enough interest in doing it twice a year, doing it IEEE VR and doing it at ISMAR? And I think as organizers, we were leaning toward doing it twice a year, but having sort of a different focus, where maybe a tentative idea, for example, was that ISMAR could be the one where we do more, where we do invited papers, or not invited papers. We solicit calls for papers, and maybe at VR we do more of an interactive session as we did this year, right? That's one option. I'm just looking at the Miro board now, and there are some questions that have make in the event that we go back to in-person workshops at some point in the future, how do we maintain the level of accessibility that is present in online interactions? I think that's a big problem for the world, but maybe especially for our community, because we do potentially can affect solutions to these problems. And there's a request to have more industry involvement if possible, and we'll try. Because I do think it would be really great to have industry representatives, possibly even to address Mary's first question, which is to say, it would be great if somebody from the HoloLens team was here to hear what we have to say about perception in the HoloLens. maybe not today's talks, but in general. Yeah,
That's
I'll leave it
kind
there
of
if
an
there's anybody else.
excellent segue. Yeah, I was going to and I was listening in on another talk some weeks back, and they kind of mentioned that similar issue where it'd be nice to have a connection with more industry people, given we don't always know what's going on with hardware. And this particular person was from industry, and I wish I could remember who they were, but they were like, reach out to us and we can work with you on that. I don't know if that's indicative of most people which I guess Missy's in industry, so maybe you'd know better. But there seem to be some groups that are willing to talk with researchers about components like this, but I don't know how feasible or like how that process would work, but at least some are open.
Yeah, I think
go ahead, Missy.
I think it depends. I mean, and this is my perception based on my time in industry so far. I think it depends on the company. Some companies are a lot more open than others. But also I think there's a lot more internal research going on in companies than it seems like as well. And so that's another thing, is that also like one of the reasons I'm here is because I'm recruiting and like looking for people that might want to one day work at places like Meta. And so yeah, I mean, I think that there's definitely interest. It's also very much up to like individual people. So I'm here because I already had connections and know it's a great place to be, and have promoted it a little bit to get, my manager's buy-in. And my new manager would be here, but he had like parents stay with his daughter. So, can't fault him for that. But I mean, I think it is about like working your network too, and making sure that they know that meetings like this exist, if they didn't already know about it from grad school, because I'm here because I knew about it, but I think there's a lot of people that would be interested. And I think Kai is a conference that just sucks in a lot of industry. That seems to be a very, we send a lot of stuff there. And so that's something for me, like I wish that we had more people at places like VR and PERCxR specifically, because it's definitely like really, really well aligned, a lot more focused. But I think there's also just like, it's what people know, what they knew in grad school.
Yeah, that's really insightful. And I'll just chime in on a thought for maybe the organizers for next time, is that the keynotes, excellent though they have been, and I thought Joe's was particularly excellent today, I took a lot of ideas away from that, have all been academic researchers, right? So if we could find an appropriate person in industry who would be interested in speaking directly to this community, maybe that's something we should try to do next time. And with that, yeah, it is 12:01 my time. It is the end of workshop time. So I will just thank everyone once again for your time, for your interest, for your participation. Please chat in the Discord, find us around the virtual conference, and yeah, it's been great. Looking forward to the rest of the week. Hope to see you around.
Bye, y'all. Thanks for coming.
To join.
Bye.
Brad to Rick.